Let us understand what is equilibrium. Understanding equilibrium relates with your understanding of moments. So the first video on this topic of moments was on understanding the basics of moments. If you have not gone through video 1, you can go through it, or if you already understand the basics of momentum, you can continue watching this video. This video is video number 2 of the 3 videos which explains everything, every technical details about moments. So here we'll be focusing on understanding equilibrium. For a system in equilibrium, system means any body, right? There are 2 conditions that must be always fulfilled. When a system is in equilibrium, the following 2 conditions have to be always fulfilled. There are 2 conditions. So what are the 2 conditions? Here you have on the screen the 2 conditions. Condition number 1, condition number 2. There is no resultant turning effect on it. There is no resultant force on it. You can take an example. Say that you have certain object lying on your table. Say your pen stand, which is right there on your table. Is it turning by any means? No. It is in equilibrium, right? How do you say it is in equilibrium? It is not moving, it is at rest. That is called equilibrium. Equilibrium means no motion, it was just lying idle, right? So the pen stand is not moving. Is it turning? If it is not moving, that means it is not turning. So there is no turning effect. There is no resultant turning effect acting on that pen stand. Similarly, there is no resultant force on it. No resultant means zero resultant force. There are forces acting on the pen stand which is lying on your table. There is a downward force of the gravity. There is force. And there is one more force. There is an upward force by the thrust. If this is your pen stand, if that's your pen stand, there is a downward force of the gravity. Let's call it the weight of the pen stand, which is balanced by an equal and opposite up thrust, or you also call it thrust. These 2 forces are equal and opposite. So how much is the resultant? The resultant is 0. The resultant is 0. This is what we are trying to explain here. Whenever there is an object or any body in equilibrium, it is not turning. You can see it with your own eyes. It is static, not turning. It is not moving. So the turning effect is 0. There are forces acting on the object, but the resultant of all the forces is 0. Let us understand it with the help of an example. So you are given a special case of equilibrium on this seesaw. So the boy and the girl that you see in this picture, there is a girl and a boy. They are sitting on the seesaw in such a way that the seesaw is in equilibrium. Seesaw is in equilibrium means that the seesaw is perfectly horizontal. It is neither moving up nor moving down. It is perfectly balanced. It is static. It is stationary, not moving. The seesaw here in this picture is in equilibrium. If you want to bring about this equilibrium, the heavier object has to be near the pivot. So what I am talking about here is moment, heavier object near the pivot. We have understood it in the video 1. So if you look at the girl, she is bigger in size. She is sitting nearer to the pivot, whereas the boy is bigger in size and he is sitting away from the pivot. So that to create moments which are exactly equal and opposite. When the moments are equal and opposite, they'll cancel out. And what is moment? Moment is the turning effect. If the moments are cancelling out, the turning effects are cancelling out, that means there is no turning effect, no resultant turning effect. So all the moment which is in the anti-clockwise created by the girl. Anti-clockwise moment which is created by the girl in this direction is equal to the clockwise moment created by the boy. They are equal. They are exactly equal, but they are opposite. One is anti-clockwise, one is clockwise. So moment is a vector quantity. They'll cancel out each other. As a result, no turning effect. No resultant turning effect. So the condition 1 of equilibrium is satisfied. When a system is in equilibrium, there is no resultant turning effect. So the seesaw here in the picture, if it is in equilibrium, the boy and the girl, they are creating individual turning effects, but the resultant of these two turning effect is nothing. It is nothing, zero. Right? Understood? No resultant turning effect. Let us come to the next point now. Next point. There is no resultant force. No resultant force on the seesaw. Let us mark all the forces. What are the forces acting here on the seesaw? Let us try to identify all the set of forces that are acting here. The girl will have a weight which will create a force downwards. Right? Weight is a force. If you do not understand that weight is a force, please go through my video on understanding mass and weight. Weight is a force. So what is the force created by this girl? Let us call it WG. That's one force identified. The boy also has a weight. This weight will also act downwards. Weight of the boy. Let's call it WB. Is there any other weight that you see here? The plank of the seesaw, this green plank that you see here, this green plank, won't it have a weight? It will have a weight, right? So the weight of the plank, let us call it WP, right? So three weights you have identified: weight of the girl, the weight of the plank, and the weight of the boy. Weight of the plank will act from its center point, the center of mass, which will be our next topic after we finish moments. So the weight of any object acts from its center of mass, which is the center point of any object. The weight of the plank is acting from the center point. WP is the weight of the plank. Are these the only forces acting here? There is one more force. One more force, which is in the opposite direction. Let me use a different color because it is in the opposite direction. Maybe I can use a blue pen. A force in the opposite direction, which we call the support force. Support force, or you also call it thrust. So every force creates an equal and opposite force. When you're standing on the ground, you're pushing on the ground, at the same time ground is pushing you up. Same concept is applying here. The girl is pushing down, the plank is pushing down, the boy is pushing down. So there is an opposite force which is equal to the sum of all the downward forces. The support force is equal to the weight of the girl plus the weight of the boy plus the weight of the plank or the weight of the seesaw. So how much is the resultant now? How much is the resultant of all the four forces that you see here? You have identified four forces. So if you add up all the four forces, how much is the resultant? It is 0. So from our understanding of finding the sum of forces when the forces are parallel, we understand that the sum of all these forces is 0. There is no resultant force on the seesaw. Why? Because the support force acting upward on the beam from the pivot must be equal and opposite to the total weight of the seesaw and the children. This is what we have written here. This is exactly what we have written here. So both the conditions of equilibrium are fulfilled. There is no resultant turning effect. There is no resultant force. So these are simple things you need to remember. Whenever any object or any system is in equilibrium, there are two simple conditions: no turning effect, no resultant force. So therefore, the seesaw is in equilibrium. Let us now solve a exam type question here. The question starts from this point. This is where the question starts. State two factors on which the turning effect of the force depends. They are saying two factors on which the turning effect of the force depends. What is the turning effect of the force called? Moment. So they are talking about two factors on which the moment depends. Moment depends on force and distance. So your answer should be force and distance. So you should be very clear in understanding what the question is asking. The question is not asking about what are the two factors of equilibrium. Do not get confused because we have just finished equilibrium. Here they are talking about two factors on which the turning effect of force depends. And we know that the definition of moments is turning effect of force. So they are talking about moment. So what are the two factors on which the moment depends? The force and the distance. All right. The forces, let us come to the B part. B part. The forces F1 and F2 are applied vertically downwards at the ends of the beam resting on a pivot P. So you're given the pivot point P. They are saying F1 and F2 are acting downwards. The beam has a weight W. The weight is acting from the center point of the beam. The pivot here is not at the center point. The pivot is somewhere else. That's perfectly possible, right? The beam has the weight W. The beam is shown in this figure as you see here. Complete the statement about the two requirements for the beam to be in equilibrium. Now they're talking about beam to be in equilibrium, right? So there are two conditions for any system to be in equilibrium. There must be no resultant turning effect. Either you say turning effect or you say there is no resultant moment. Why? Because moment means turning effect, right? There must be no resultant force. So second question also. Part B, I part is done. Now let us come to second part, II. The beam in the figure is in equilibrium. F is the force exerted on the beam by the pivot. So this is the force that they are talking about. It is the force exerted by the pivot. Now they are saying that the beam is in equilibrium. The beam is in equilibrium. Complete the following equation about the force on the beam. If the beam is in equilibrium, the resultant force has to be 0. This is what he said, right? In equilibrium, resultant force is 0. So all the upward force, which is F, should be equal to the sum of all the downward force. So this should be your answer here, right? Because it is in equilibrium, the question says that the beam is in equilibrium. You have to read the question multiple number of times to find the key terms hidden in the question, key hints hidden in the question. The beam is in equilibrium, right? They are telling you to find F in terms of the other forces. How do you find it? But you apply the So how do you find F? You apply the यार कहाँ से शुरू करना है So how do you find, ti answer should occur. So how do you find F? F should be equal and opposite to the other forces. Which one of the four forces on the beam does not exert a moment about B? Which force is not exerting a moment? Which force is not exerting a moment? Think about it for a moment. You can pause the video here, solve this, and you can play the video again. We are on part number 3. So which force is not creating a moment? It is force F. Why? Because its distance from the pivot is 0. So therefore its moment is, which is F times distance, it is 0. Simple. If a force is applied right on the pivot, it will never create a turning effect, right? So if I'm holding a pen like this, and if I'm trying to push the pen at the pivot itself, it will not turn. It will rather move the pen. I'm holding the pen at this point, which is the pivot. I apply the force on the pivot. Will it turn the pen? No. If you want to turn the pen, you have to apply a force away from the pivot. If I apply the force here, it will turn. This force will turn the pen, right? But this force which is on the pivot will never turn. That's why the moment of a force which is applied at the pivot is 0. So which one of the four forces on the beam does not exert a moment? It is the force F. Why? Because it is applied right at pivot. Alright, so this is where we end this topic on understanding what is equilibrium. We'll finish this understanding of moments by completing our third video on moment, which is on the principle of moments, and this is going to be your next video.